Hello everyone. Yeah, I'm back with another module. So for this video, I will explain about module 5, which is machine learning part 1. Why I say is part 1 because I think this like a basic of machine learning. So what I did is like to build model and then compare their ability, but all models apparently is supervised model. And for this module actually there are 4 problems, but here I wrote 5 problems because actually there are one additional problem that come together in one number. So here the assignment is like I need to build like 3 models plus one baseline model and then compare it with the provided model. So what we use for this model is like a data from polarimetric radar parameter retrieved from disdrometer measurement in Huntsville, Alabama. There are like several parameters in the raw data. Maybe I can show you. This is like the data. So yeah, there is like six or seven parameters. Like the name is like radar reflectivity with the units like dBz, and then differential reflectivity. This one is like the unit dB, and then the linear depolarization ratio. There is like specific differential phase, and then specific attenuation in dB per kilometer, also differential attenuation or IDR and dB per kilometer, and the last one is rain rate in millimeter per hour. Basically in this model we need to predict this one rain rate for the machine learning, and also another additional equation. But here actually in this data the rain rate is already there, but they calculated using metrics and already in the data. So in here the first one actually the problem is asks us to have like splitting data into with the ratio 70 for training and 30 for test data. But here I say that the most difficult or the most time consuming when we talk about machine learning is like data preparation. Thankfully for this data it's already there, and then and it's good enough to be trained. But if you train like for really raw data, you have to make sure that the unit and then the name of like the column, even like the none, also the number of data, it should be proper enough to be trained. In here you can try by looking the data like what I did. First one is of course matplotlib, and because of this is talking about machine learning and this is the supervised one, so the model that we need like sklearn, you just need to like install it, and this is the models that we need. It's just like matplotlib for the plot, numpy numpy and panda for handling the data, and then sklearn matrix for calculating the statistical value, because the problems ask us to compare in this statistical, especially in the R square score and also the root mean square score. And then this is code for load the data because it's GSV, so like this one, so just use the panda. And then we have to know like what's in the data, and in the data there are like actually eight columns, 8 columns with like this one like unknown volume or maybe unwanted volume. That's why in here I drop the unnamed data. And then like I said before, because in the preparation we need to know the data further, that's why I try to like describe the data. Just want to know like the minimum, the counted, the number of the data, and then if it's like quite make sense or not. Like for the dBz, for example, like for reflectivity, the mean is like 31 dBz, something like that, and then the maximum is 57, and it's related to like convective cloud, or strong signal of the cloud and something like that. And then sometimes you can use like seaboard if you want to plot all the data. But here I didn't do it simply because like yeah, it's just enough to know like about the statistic without like any what is like yeah, to know more about the data. And then here, yeah, because that's why I said that there is 5 problems, because there is one additional problems that asks us to calculate the rain rate based on power law equation, or called as a baseline model. Yeah, and the equation is actually, if I'm not mistaken, is related to constanta Marsh-Palmer or something like that. Yeah, so it's so the z, we need to know the z, and the z we can derive from dbz. Yeah, because we already have dbz, so we need to solve this one to get dz, and then to get rain rate we have to solve this one. This called is like a low power equation, or like if you are more familiar with constant Marsh-Palmer, if I'm not mistaken. And then yeah, and this is like my equation is quite it's quite simple. You can like combine them if you want. You can also use like a function or something like that, but because it's so simple, so I just like add another column with name is our baseline. Yeah, it's like it's for calculating this equation. And then yeah, because in the end we need to compare this baseline with another machine learning and also with the provided rain rate. So I also calculate the R score and also the RMSE, and then just print it just like this one. The R quadrat is very low to be compared with the new one. We can see the scatter later on. And then number 2, no, actually still number 1, but in here I need to make sure that there is no none value, and then yeah, make sure that I have the features data and the target data. That's why in here X is a feature data. Simply I combine all the column in my data with this number, with this variable, and then the Y is the target, or the provided from this disdrometer for rain rate. And then for the splitting or for the division or of the train and test data, I use like this one, like you need to import train test split, and then yeah, just train size for 70 or 0.7. Basically the default one is 70, but if you want to change to 50 or like maybe highest like 90, it's also, yeah, it could be, but just change in this variable. And then the second one, I need to build like multiple linear regression. There is nothing much in the setting because like we just need to build and then compare. So in here I just called like the module of linear regression, because we have like several features, so we can say that it's like kind of multiple linear regression. And then for here I just like run it. It's quite for me, it's like very super fast actually. And then I calculate the R square and also the RMSE. Apparently the R score is like getting higher, yeah, like it's higher than the previous baseline. And then the third one is like a quite already complicated about this model, especially the problem asks us to have like cross validation until 7 folds. For those who are not familiar with cross validation, maybe you can search, or maybe you can read more about cross validation in this like machine learning book or something like that. It's like basically it's all about validation in which we switch the train and then test data in a 7 times. Yeah, in a 7 times. Actually it's very nice if I can explain with the figure, but yeah, maybe yeah, it's basically just divided into 7 scenario, and then you switch it between the train and the test data for the validation, something like that. And then actually the teacher asks us to have like 20 21 degree for the grid search for the polynomial. But yeah, actually I use like my our department's per computer name is Killing, but Killing doesn't but Killing couldn't calculate until more than 7, and if I'm not mistaken, and it keeps like getting error because of like computation limitation. That's why I moved to my local computer. This one is like M1 MacBook Air with if I'm not mistaken, RAM is of 8 GB. Yeah, 8 GB. So I tried actually I tried like several times from 9 until yeah, because I already get like a 7 degree from the skilling. That's why I increased for 8, 9, and 10, and then this computer can calculate until 10 degree with quite yeah. Actually I'm not very patient. I was not very patient to wait. That's why I decided until 7 degree, because it's already like taking almost 58 minutes in this computer. Maybe yeah, for different specification of your computer it will be different, but for my computer, yeah, I think like if I try like more than 10, it will be very longer. That's why because this very long and this is that's why I saved it. And actually this is like the result of the model. If you already train and get the equation that you need. This one is like 10 degree, and then in polynomial features, and then just save it. Yeah, in here I save it because I don't want to run again, and then I just open it, and then yeah, I want to know like because it's grid search, so we need to know like what kind of parameter or like hyperparameter that best for this polynomial. Apparently like the best is like in 2nd degree. So yeah, so I think if we like train the data until like 3 degree, it will be enough, because the best one is in the like 2nd degree. So I don't think you have to suffer until like 10 days 10 degree, because your computer will be not happy at all. And then just like predict with the test data, and then yeah, I already get it. And then yeah, this is like the R square and also the RMSE. It's quite good because the R square is almost like 1 is almost perfect. I don't know whether it's like overfitting or not, but the RMSE also is quite good, because if we compare with the previous one, it's like 7 point something, especially for the baseline. So in here it's quite good because like it's close to 0 for RMSE. And then for random forest progress is number 4. The problem, the teacher asks us to have like this one, this hyperparameter to be trained, and then use the best hyperparameter to predict the data. So here for the number estimator, max feature list, max depth list, and then minimum sample split, minimum sample leaf, because it's random forest. So we need to like certain leaf and certain what is not bootstrap, what is that? I'm so sorry, I forgot the English name, something like that. And then just and then define it to random forest grid for this one, what you already defined. Yeah, this is like another time consuming module, because the module has to train the train data with this kind of hyperparameter. And for me it took like 1 hour and 50 minutes for this computer. It's very very long, and this is like the result of my model. And as usual, yeah, as previous steps, as previous model, I also saved it and then call it again, because I don't want to suffer anymore. And then for the best parameter for the train model is like here. So the number estimator should be 200. Oh, sorry, I need to explain that for this one, I use iteration only 100. Yeah, because actually I want to try like 1000 or maybe 500 like in the example, but apparently my computer in killing was not happy at all, and in here also took like very long. Believe me or not, I waited like almost 3 hours. Then that's why I just scaled it and then go with 100. And here the best parameter for the hyper what we already trained. So the estimator is 200, and then the minimum sample split is 2, minimum samples left is 1, and the feature is auto, and the depth is only 50, bootstrap is true, and the best score for all the train data is like 0.9. So simply that this parameter give us like this number. So from here we use the best params for our model to predict our data test in here. So I just fit it and then use with the best parameterization. Yeah, and then here I calculate the R score and then the RMSE, and actually it's quite good, but not as good as a grid search polynomial, even though the polynomial only fitted to the second degree polynomial. And here what kind of data and the model you visualized. So I plot it into like subplots matplotlib, like just common matplotlib, and then we can just try it supervised. Yeah, here because we already have 4 models, the baseline, multiple, and then search polynomial, and then random forest progressor. Here is the result. So we can see that in the y label is a predicted rain rate, and then in the x axis is like an actual rain rate. We can see that in baseline the R score is very low because the model simply like over predicted to be compared with the actual one, and also the RMS is quite bigger, like until it hits until 7.15 millimeter per hours. And for our multiple linear regression, actually it's super fast. It's like takes me maybe like 0.2 seconds, but the R square is better than the random forest that took us like that required me to wait until almost 2 hours. Also for the RMSE, it's quite good, like 0.9 and 0.9 for R score, and then RMSE is 0.95. And the best one is like a grid search polynomial regression. Yeah, because we can get R square almost 1, and it's really perfect. Maybe if I round it, yeah, because actually the number of floating like 12 or something like that, but it's too long. That's why I round it until 5, a floating number. Maybe if I just round it until 1, or maybe without floating number, it will be 1. It will be perfect. And so yeah, the best model from this supervised machine learning apparently is grid search polynomial regression. We can see that maybe our data is almost like a second degree polynomial instead of like a random forest or something like that. Yeah, so sometimes we see that sometimes random forest is good, is better than the regression, but here maybe it's also related to the data. Because of the data maybe more closer to the to polynomial, so it will be more fit. So this is like the end of explanation of my 5 module, and here is like the readme you can find in this one. And then conclusion, the best model to predict rain rate using the provided feature based on R square and RMSE is apparently grid search polynomial. You can see from these scatter plots. And reference, you can just click here. You can go to this one is scikit-learn from the Python, and then from the sklearn itself you can see this one. I think I made a mistake. It should be go to somewhere, not the clearn but to Python handbook. Maybe uh, I will do it. I will change it after this video. And then full code can be found on here. So here is like the full code that I show you before in my Visual Studio Code. So this one, thank you, happy sharing, and bye bye.